Morning once more again. Welcome to this session. So before I start with the lecture, let me just give you this important announcement. I hope some of you have already noticed that I sent something on Blackboard, but for those who don't check the Blackboard very often, I think it is very important for me to announce this. So it's about a quiz. Your quiz marks are ready. I can just release them at any time, especially from 1 o'clock after this session. I will be releasing your quiz marks. So another thing is about the session that I've created during tutorial session. We are going to discuss about the quiz marks, or I'm going to give you the feedback about the quiz that you have written. So we are going to talk about the quiz in detail during our second session. So I hope that there will be no one who will be asking any question related to the quiz, as we are going to talk about it in our next session. I think it's clear to everyone. Unless if you have any question, but otherwise we can start with our session. To give you a reminder, because you were not here for the past week, and maybe some of you, they have already forgotten about what we've done so far. So let me just give you just a hint of what we've done. If you still recall, we talked about the moving average process. Then from there, we moved to the autoregressive process. Then later, we combined the two as ARMA process. ARMA in the sense that we have got autoregressive of order P and a moving average of order Q. Then later we included the seasonality, where at the end of the day we have a new process called SARMA, that is the seasonal moving average, seasonal autoregressive moving average process. Then later we realized that, okay, if the process is not stationary, we have to difference it. That is where we just included the integrated part, where we are integrating autoregressive and the moving average there, where we produce the new model as well, called SARIMA, which is read as seasonal autoregressive integrated moving average processes. So I think this is where we are. So I gave you an, is it an example or is it an exercise? I can't even recall, where you were using the SARIMA process to calculate the autocovariances and autocore. No, I'm not writing something here. I'm just giving you a scenario, just explaining without writing anything. Don't worry about that. It's just the matter of just reminding you of what we've done so far. So I said I gave you the SARIMA model, where you have to calculate the autocovariances. If I still recall, I gave you even the solutions there. So what I can ask is, have you able to get those answers? Did you get the answers? Anyone? Okay, that's very good. There are those who got it, so it's fine. So now we are still going to continue with the SARIMA model, or ARMA or ARIMA models. where I'm going to show you how do you identify the model if they gave you the autocorrelation plot and partial autocorrelation plot. So let me just go to the notes, lecture notes, so that I can start showing you how to do that. Let me just go there, share this file. Okay, still opening. This is the document, but we are looking for a certain page here. Let me just look for it. Be patient. Patient. Yes, I'm still scrolling. Okay. Let me just scroll again. There we are. Okay. This is what I'm going to talk about. I wonder whether you can be able to see it. Okay. Can you be able to see these two plots or two figures? Anyone?
Yes, sir.
Okay, thank you very much. Okay, this is the two plots for the partial autocorrelation functions together with the autocorrelation functions. Now, let's start with the autoregressive. If you just want to identify a model, okay, while you have been given the partial autocorrelation functions, you must know that in a partial autocorrelation function, you just want to identify autoregressive where it cuts. Okay, if you can check the first plot on your left, there is an autocorrelation function and partial autocorrelation function there. Now, for partial autocorrelation function, if you check these two plots there, where I have indicated with the blue pen there, so the first one indicates the autocorrelation plot, and the next one indicates the partial autocorrelation plot. Now, for partial autocorrelation plot, you check where autoregressive process cut. If you can check this, there is a peak there. That line, this one, this line, we call it a peak. Okay, and that peak, to check whether that peak is significant. Significant, we mean that it's big. It is above the boundaries. Actually, here we were supposed to have the boundaries. Here, we were supposed to have the boundaries here, the lower bound and the upper bound. If the peak is above the boundaries, we are saying that that peak is significant. And then if you check, we have only one peak, and it is at leg 1. That is leg 1. And this is the only peak that is significant. The rest are insignificant. They are insignificant in the sense that all of them are zeros there. They are zeros. They are zeros, all of them. Okay. So because it's a partial autocorrelation function, we are thinking of getting autoregressive. Okay. So the question is autoregressive of order what? Because we've got only one significant peak there at leg 1, so we can say it's an autoregressive of order 1. Why autoregressive of order 1? Because it cuts after leg 1. So that means the only peak that is significant is at leg 1. The rest are zeros. So that is why at the end of the day we say it's autoregressive of order 1. Then coming back to the autocorrelation on your left, this one, it shows that it dumps through to 0. It started with 1 there, at 1 there, and then it goes to 0. So autocorrelation function at leg 1, it dumps to 0. In autoregressive, it dumps to 0. So that is why here, under context here, we are saying that there is a dump out. Dump out meaning that it tends to 0 gradually. Okay. So in autocorrelation function, autoregressive die out or dumps out or tends to 0 gradually. But in partial autocorrelation, it cuts somewhere. So, but in this case, in that plot, it cuts after leg 1. So that is why we're having autoregressive of order 1. Okay. So now let's go to the second. Let's go to the. I will explain it by writing later. Yeah, I just want to show you the plots because you can be able to see it. Then later I will explain it fully so that you can understand it well. So on the other figure, figure number 2, the one on the right, you can see that partial autocorrelation plot, this one, it is having 2 peaks that are significant. Okay, 2 peaks that are significant, this one and this one, they are significant. So the peaks are at leg 1 and leg 2 respectively. And the rest, leg 3, leg 4, leg 5, all of them are dumped, they are zeros. Okay, so because in partial autocorrelation functions, we've got 2 peaks that are significant, we are expecting to find autoregressive of order 2 because it cuts after leg 2 under partial autocorrelation functions. But when you come to this other plot, this is an autocorrelation plot, it dumps out. Again, it tends to 0 gradually. So when you want to identify a model, if they gave you the autocorrelation function and partial autocorrelation functions, to identify the autoregressive, you go for partial autocorrelation functions, and then you check where it cuts. Okay, so in this case, cut after leg 2, so that is why we are having autoregressive of order 2, this one. For the first one on the left figure, we said it cuts after leg 1, so that is why we are having the autoregressive of order 1. So this is all about partial autocorrelation functions plot. Now, let me just go to auto moving average, sorry. I think this is the one. Yes, this one is a moving average. Again, we've got 2 figures, 2 tables. Figure 1 is on the left. This one, figure 2 is this one. So in a moving average process, we check for autocorrelation plot where it cuts. Remember, in the autoregressive, we check where partial autocorrelation, where autoregressive cuts in partial autocorrelation functions. But here, we just consider the autocorrelation functions. Then we check where it cuts. So the left plot here, which is this one, okay, it's autocorrelation plot. If you check, there is a peak there which is going down. Okay. That peak is significant.
Yes.
Yes. Yes. You can ask. Do you want to ask a question or do you want to comment something? Okay. I'm saying here we have got the autocorrelation plot, which is the one that I tick it there. So there is a significant peak which is going down there. So because it's the autocorrelation plot, and there is one significant at leg 1 which is going down there, so we are expecting a moving average of order 1. So in other words, it cuts off after leg 1. The rest are zeros. So that is why we're having moving average of order 1, because now we are considering what? Autocorrelation functions. And then for partial, this one there, it gradually goes to 0. So that is why it's like that. So in partial autocorrelation functions, moving average gradually goes to 0. In autocorrelation function plot, moving average cuts after a certain significant leg. So in this case, we have only one leg which is significant. So that is why we're having moving average of order 1. Okay. So now, if we check the next figure there, where we have the autocorrelation plot and the partial autocorrelation plot there. So for autocorrelation plot, again, we are expecting moving average of order something. So if you check those peaks there are two. All of them are significant under autocorrelation functions. So because they are significant, all of them, from leg 1 and leg 2, so we are expecting moving average of order 2. Okay. So now, let me just explain it by writing. Let me just go to the...
Sir,
Yes, ask.
what about the graphs at the bottom?
Come again.
What about those graphs at the bottom?
Or at the bottom. Okay, let me just... Oh, it's still the same. They mean the same. Okay, let's go to the one on the left. This one. You see that there is a significant peak there under autocorrelation plot. And it's above. Remember, the one up there, above there, it was below. Significant peak was below. But here, on the second one, below that one, the significant peak is above. But it's at leg 1. Okay? And those are the positive values. And remember, the one there up there, it was negative values, but at leg 1. Okay? So that is why we're having a moving average of order 1 for both of them. Because we have a significant peak at leg 1. It doesn't matter whether it's negative or positive, as long as it's only one significant peak, so we have a moving average of order 1. Okay. So the same applies to this one. It's a zigzag. It shows you that it goes to negative, positive, negative, positive. So, but goes to close to 0. If you check, it goes close to 0. So we take it in partial autocorrelation functions. Moving average goes to 0, but for autocorrelation plot, moving average cut after a certain leg, provided if it is significant. So because in this case, we are having one peak which is significant, so it's a moving average of order 1. The same applies here, because here we've got only one significant peak, even though it is below, we are having moving average of order 1. Okay. So coming to the next one, we had two significant peaks that are there on the autocorrelation plot, this one. Then that is why we say it's a moving average of order 2, because it cuts off after leg 2. The same applies to this plot below there. There are two significant peaks. The one is above the line, the other one is below the line. The one above the line is at leg 1, and the other one below the line is at leg 2. So because it's an autocorrelation plot, it's a moving average of order 2. The moving average of order 2, why? Because it cuts off after leg 2, because the rest are zeros. Okay. Any question? Okay, let me just go and explain it. Why? Okay. No, I'm not writing. I was just indicating. I have not yet started writing something. Okay. So, but now I just want to go and write so that you can understand this better. Let me just go then. Let me just go then. Okay, it's still coming. Okay, let me just try to explain it here, whatever I was doing. This is lecture 17. We are talking about the autocorrelation function plot. Okay. And a partial autocorrelation function plot. Okay. There are two plots there. So for autocorrelation function plot, okay, here we are expecting a moving average, where a moving average is going to cut. Okay. And here it's autoregressive process going to cut. So if you have got two plots, autocorrelation function plots and partial autocorrelation function plots, you must decide between moving average and autoregressive. Okay. Then for moving average, you know that you have to consider autocorrelation plot, function plot. And for autoregressive, you have to consider the partial autocorrelation plot. Okay. So now, let's say you have got this type of a plot. Let me just write it like this. Okay. So we've got 0 there. So 1, 2, 3, 4, 5, 6. Those are the legs. If you still remember, it's leg K. Okay. And this one represents row K, meaning what? Autocorrelation function plot. And then this one goes this side. So this one is leg 1, leg 2, leg 3, leg 4, 5, and 6. Okay. Now, let's assume that you have got, and remember, we have got the upper bound and the lower bound. It's unfortunate because in that plot that I was showing you there were no upper bound, there were no lower bound, but we're just assuming that the peaks were significant. But another thing that can show you that is the peak significant or not are the bounds. So you have got the bounds like this. Okay. So this one we call it the upper bound. Okay. And you have got another one this side. Okay. It's a lower bound. Okay. Now, let's say you have got the significant peak at leg 1. Significant in the sense that it's above a bound there on the positive. It's about a peak, a bound. You see, it's a significant because it's about that line. Okay. And then when it comes to leg 2, it's 0. So in other words, it's insignificant. Leg 3 is 0. Leg 4 is 0. Leg 5 is 0. All of them are zeros. That means they are what? They are insignificant. Now, because this one is autocorrelation function plot,
Sir,
we...
morning, sir.
Oh, morning, how are you?
Yes, sir. I want to ask, when you are writing the test, are you going to give us those boundaries, or we are just going to assume, or if we have this line, vertical line, which pass on leg, the different legs, we are just going to assume they are significant, or you are going to give us the bound when we write test?
I think I will give you the plots that are having the bound. You will see them that this one is having a bound and then is significant. Even though if there are no bound, you saw those previous plots. You can see that the two are significant because they are visible there. The rest are they are not visible. They are close to zero. In other words, they are zero. You can see them that there are zeros there. Oh. It's not a difficult thing to identify whether the peak is significant or not. You will see them. Okay. But normally, in many books, they have the upper bound and the lower bound to just check whether indeed the peak is significant or not. By significant, we mean that it's above the bound. It can be above the upper bound, or it can be above the lower bounds, somewhere there. So now let's say you have got this peak, which is significant at leg 1. Okay. And remember, this is the autocorrelation function plot. So therefore, we're expecting a moving average. Okay. Of order what? So it's going to be of order 1. Why? Because it cuts off after leg 1. The rest are zeros there. Okay. That is
Morning,
a
sir.
moving average. Yes. Yes,
Sir,
yes.
may you please elaborate on something? Do we only say it's significant when it's approaching the leg that you have given us? For instance, in
Not
this
it's approaching, it's above the line.
above the leg, that's when
Yes, that is
is
significant. Yeah,
so only when it's above the leg that we are given, that's when we conclude that it's significant.
definitely.
Okay, sir.
If
And
it's
then
below, come again.
and then I was about to say when it hits like directly on zero, that's when we conclude that it's insignificant.
Or if it's like this one, let me just give you another one. At like 2, let's say you have got another one which is here. You see this one? It
Yes, sir.
doesn't pass the bound. It's within the limits. So this one is insignificant.
Oh, okay.
Yes, it's insignificant. But that other one for leg 1 is significant.
Okay, so
So
thank
now
you.
let me just give. Okay, thanks. Let me just give you
So,
another
sir,
scenario.
sir,
Yeah.
sir, my question come back again. Okay, since
Mm.
it means what you are saying is mean if we are given the bounds, we are going to
Mm.
use the knowledge, that notion of concluding based on the bounds. But if we are
Mm.
not given the bounds, we are just concluding because we see the line.
Yeah,
Or
yeah. You will see. Yes, you will see. You will see that there are two lines. The rest are going to be insignificant. I think so. If there is no bound, you will see those lines that are visible, which are big,
thank you,
like in
sir.
the previous scenario there. Did you get it?
Yes, sir.
Okay, so it's fine. So now I was saying, let me just give you another scenario where you have got this. See this one. Both of them are significant because they are above, not meaning that they are equal. They can be not be equal, but they're above that line. Okay. So in this case now, leg 1 and leg 2 are both significant, but when you check leg 3, leg 4, 5, and 6, all of them are insignificant. So they are zeros. So therefore, you can end up saying that, okay, because it's a moving average process, we have got a moving average of order what? Where it cuts? It cuts at leg 2. So it's a moving average of leg 2. moving average of order 2, sorry. I think it's clear about the autocorrelation function plot. Okay, now let's come to the partial autocorrelation plot.
Sir.
Yes.
Okay, on leg 2, the peak is above the upper bound, and then you said is a moving average of order 2. So if the peak was below the upper bound, we're still going to say this diagram is a moving average of order 2.
Yes, it's of order 2 again, even if it is here like this, and this one if it's here, or maybe they alternate. Let's say you have this one which is above, okay, and this one which is below, but all of them are what? Are significant. See, this one is significant and this one is significant, and this one is for leg 1 and this one is for leg 2. So it cuts after leg 2 again. So again it's a moving average of order 2, the same thing. Okay, I think it's clear. Okay, now let's go to the partial autocorrelation function. The interpretation is still the same. Okay, however, in this case we are going to consider what? Partial autocorrelation plot. Okay, let me just go to the next page. I don't want to tamper with this one. If you want to ask something, we'll go back to it. Okay, now we're having a partial autocorrelation function plot. Okay, and I told you if you have a partial autocorrelation plot, you have to consider autoregressive where it cuts.
Sir.
So let's say, yes. I'm listening.
Sir.
Yes.
Does the significant and significant affect the order of the, order of the moving average or the autoregression?
The what? The significant. Yes. Yes.
Yeah, the significant and the significant. Meaning to say that if we have one, can you please go back to the example? I wanna see something.
Yes.
Let's say we have here. So let's say that we have a line that is insignificant and a line that is not significant.
Yeah.
So which means that, so what can we say about the order of the moving average?
Okay, let's say for example, which leg? Leg 1 is significant, ne?
Yeah, but leg 2 is not.
And then let's say
leg 2 is not significant. Okay, if
yeah,
leg
let's
1
say
is
it's not.
Come again. Okay, let's say you have got leg 1 which is significant and leg 2 is not significant. Okay, if leg 2 is not significant, we consider the one that is significant, which is leg 1. So it's a moving average of order 1. Even though there are two, but the other one is insignificant, the other one is significant. You check the one that is significant. Which leg is there? It's leg 1. So if it's leg 1, so it's a moving average of order 1. If leg 1 is insignificant and leg 2 is significant, you check the leg which is significant, which is leg 2. So it's a moving average of order 2.
Oh, okay, yeah. Now I'm fully getting it. Thank you, sir.
Okay, it's fine. So coming to the partial autocorrelation function, let me have a plot which is like this. Remember, this one now is a partial autocorrelation plot. It's no longer an autocorrelation plot. Partial autocorrelation plot, if you still recall, we were indicating them by phi, k, k. You still remember that? Phi kk is indicate the partial autocorrelation plot. So here you are going to have 0. So like 1, 2, 3, 4, 5. Okay, let's say there are 5. 1, 2, 3, 4, and 5. Okay. Now, because it's a partial autocorrelation plot, we are expecting autoregressive where it cuts. Autoregressive of order what? We don't know. So now we have got the limits there. We have got the limits there, which is the upper bound and the lower bound limit, or lower limit, or lower bound, whatever you can call it, but they are the limits. Now we have got this peak, which is insignificant but still within the limit, and then you have got this, which is significant even though it's going down on the negatives, but it's significant because it's crossing the lower bound. Okay, and then you have got this one, and then you have got this one, which is significant even though it's above there. So, and this one is what? It's insignificant. Let's say even like 6, like 7, all of them now are insignificant. So this one is significant and this one is significant. So you can say you have got the what? The autoregressive of order 4. Okay, but even this one is significant for moving average of for this one, for like 2, but it's an autoregressive of this one. So somebody can take this one and another one can come back to this one, to this one. You see this one, because at like 2 is significant and like 4 is significant, but here like 1 is insignificant and like 3 is insignificant. So if you write this, so it's autoregressive of order 4 because the rest is going to be, but somebody can just write it like this one and say, okay, even autoregressive of order 2. But the problem is you can't say this one now it cuts. It cuts because there is another one here which is significant. So in other words, it's autoregressive of order 4 because it cuts off after leg 4. You see that? It cuts off after leg 4. So therefore it's autoregressive of order 4. But in some cases, they can just say, okay, it's autoregressive of order 4 and autoregressive of order 2. Then they say which one is the best. If you are comparing the two, so autoregressive of order 2 will be the best, in the sense that there is a principle called parsimonial principle there. If you want to come up with the best model, there is on page 18, for those who are having the lecture notes, I talk about principle of parsimony. This is where it comes in. If you have got autoregressive of order 4 and autoregressive of order 2, so the best one can be autoregressive of order 2. Why? Because autoregressive of order 2 is smaller than autoregressive of order 4. So the process here, autoregressive of order 4, is big compared to autoregressive of order 2. In other words, what we're saying is that AR4, if you are comparing the two models, can be written as xt equal to phi 1, xt minus 1, phi 2, xt minus 2, phi 3, xt minus 3, plus phi 4, xt minus 4. You see this one? It's an autoregressive of order 4. But when it comes to AR2, xt equal to phi 1 xt minus 1 plus phi 2 xt minus 2. There is a white noise there, zt, of course, plus zt. See, this one is bigger than this one. So in terms of principle of parsimony, so autoregressive is the best. But this one, you compare them. If you have got two partial autocorrelation plots, if you have got this one, okay, and another one where autoregressive of order 2 is the best, then if you compare those two, you have to take this one autoregressive of order 2 as the best because of parsimonial principle. That one, it applies only on parsimonial principle. But when it comes to identifying the model in partial autocorrelation plot like this one, so you have got the autoregressive of order 4 there. Any question?
So, sir, what you are saying is that for us to compare these plots, we have to have
Yeah.
we have to have two plots. The ones
Yes,
which will
yeah.
indicate the leg 4 and the other one which represent the leg 2. That's where we can use
Yeah,
the
you can
parsimony.
compare if you want. Yeah, if you want to take the best one.
Okay, but if we have one plot, we are just going to identify.
Yeah, in that one,
Thank you,
we're
sir.
just going to give. So now let's come to the seasonality. Okay, or maybe before you yeah, let's come to the armor, because here we were dealing with only the process of autoregressive and another process of a moving average. Now coming to armor, remember armor is just the combination of what? Autoregressive and a moving average. So that means at first we had an autocorrelation plot, then next you have the partial autocorrelation plot, and in autocorrelation plot we identify your moving average. Okay, let's say if you're dealing with of order 1, this one, and then later you have another plot, partial autocorrelation plot. Let's say here this one is significant. Okay, at leg 1, you find that this one now is significant here. Oh, I can use the new one, so because this one we've already spoken about it. Oh yes, you can just take this one, the first one that we did for autoregressive moving average of order 1, and then this one autoregressive of order 4. Okay. So if you just want to talk about armor process, it's the combination of the two, moving average and autoregressive. So you are going to have armor what? 4-1. You get that? So you get your moving average in autocorrelation plots. Then you get your moving autoregressive in partial autocorrelation plot, which is autoregressive of order 4. That side you got a moving average of order 1. So to get armor is just the combination of the two, because they said it's a mixture of the two models. Okay, so that's why we are having what? Armor 4-1. So it's simple. After getting the moving average and autoregressive, combine the two is simple, because now you know the order of a moving average, you know the order of autoregressive. That's why at the end of the day, you are having armor 4-1. Okay. So let's say if you are dealing with another plot, autocorrelation plot, you find the moving average on the first one of order 2. Okay, and on the second one, let's say it's still the same thing. It's autoregressive of order 4. So again, your armor is going to be 2-1. Just the matter of combining. This one is very simple. So now, let's include the seasonality. So what about if you just want to include the seasonality? How do you do that? Okay, let me just give you a new scenario when you have a seasonality. Can I go to the next page?
Yes, sir.
Okay. So in this case, we want to deal with the seasonal. Seasonal armor. So you know that autoregressive is order P, and then moving average is order Q. Then because of seasonality, you are going to have another seasonal part there, which is capital letter P, and then capital letter Q, then S. Okay, so you just want to look at this scenario in a plot. Okay, let's start with the ACF plot. In this case, you are going to have row K, leg K. So it's 1, 2, 3. Let's say 4, 5, 6, 7. Let me stop here at 8. Okay. Here's 1. Okay. And then you've got those limits. Okay. You've got those limits. You've got those limits. Then you have got a significant peak at leg 1. This is significant. Okay. Then you find that at 2, 3, they are insignificant. So they are zeros. Okay. Then at 4, you find that what is significant. You find that 5, 6, 7, all of them are insignificant. Then you find that at leg 8 is significant. See that one. Now, remember that S is for seasonal. And S is equal to, if S is equal to 4, so that means you are dealing with what? The quarterly data, isn't it? But if S is equal to 12, that is a monthly data. Okay. So now, for seasonality, you check where the peak is significant under 4, 8, 12, and so on for quarterly, and under 12, 24, 36, 48 for monthly data. So in this case, if you check, you have got 4 and 8 that are significant. So normally, you are dealing with the what? With the quarterly data there. Okay. So this one at leg 1 is non-seasonal, this one. At leg 1, even though it's significant, and remember, we are expecting moving average of order something for the first peak at leg 1. So it's for order what? 1, isn't it? Because it's significant there. But this one now is not non-seasonal, it's seasonal. 4 and 8 is seasonal. So that means you are going to have SMA. SMA of order what? Of order 2. Sorry, of order 2. This is of order 2. We are saying, we don't say of order 8. Remember, it's of order 2 because for seasonality, order 1, we take it as 4. Then this one is order 2 for seasonality under quarterly data. So we have got the non-seasonal part, and we have got the what? The seasonal part. So we just want to fit what? To identify this one. Sarma, sorry, not Sarima. Sarma, PQ, PQ. So the first part is going to be what? To be 1, but anyway, because now we have not yet identified for partial autocorrelation function. Eh?
Why is the leg 1 not seasonal? Or why are you saying 4 is seasonal?
Your voice is very low. I can't hear.
Why is 4 seasonal? 4 and 8.
Yes, 4 and 8 are seasonal.
Why?
because here we are dealing with the quarterly data. If S is 4, so that means it's a quarterly data. A quarterly data is started with 4, 8, 12, 16, 20, and so on. That is the quarterly data. But if it was a monthly data, your S, the order 1 is going to be 12, 24, 36, 48, and so on. So that is why we are saying this 4 now is no longer what? The non-seasonal, it's a seasonal one. 8 is a seasonal one. Okay, but if we are not talking about the seasonality, if the seasonality is not there, so normally we are going to have like 1 which is significant, and if this one is insignificant, so therefore there's no seasonality, and if this one is insignificant, there's no seasonality. These two, there's no seasonality, so we will be having only moving average of order 1. But because of these 4 which indicate the seasonality and this 8 which indicate the seasonality, so that's where we are going to have a quarterly data. That is why we are going to have order 2 under seasonal moving average there. Those like 8 and like 8, that shows us this. Now we are dealing with the seasonal something, seasonal moving average or seasonal autoregressive, depending on the whether we are checking autocorrelation function or partial autocorrelation function.
So say, what if our data is only ending at 4?
Come again, your voice is very low.
What if our data is only ending at 4? We only have 1 and 4 as significant.
4 is ending here, so we don't have this one. So that means here you are going to have SMA1. If it's ending here at 4, so you are going to have SMA1. So it's a seasonal moving average of order 1 under seasonality.
Okay, and then if only 4 was significant,
Or if only 4 is significant and 8 is not significant, again,
I mean,
remember we are
8
saying
and
it's
8
order
and 1 are
1
not
because
significant,
if 1 is not significant,
and
so
8,
and only 4 is significant.
yes.
So therefore, you don't have this one. You don't have a moving average of order 1 non-seasonal. So you are going to have only this one.
Oh. All right.
You get it?
Yes, sir.
Okay, it's fine. So now remember, we are still in autocorrelation function plot. We have not yet considered the partial. So that means here for autoregressive, you don't have it. Okay. So you are going to have a moving average of order what? Of order 1. Then the under seasonality for autoregressive, you don't have it. But for moving average of order 2, then S is 4. Yes.
So may you please explain how we find the seasonal moving average again when we're given this plot?
Okay. For both order 1 and order 2. Okay, let me just erase it. Which one?
Okay, the seasonal moving average 2.
Oh, 2. Okay. I'm saying this is the autocorrelation plot. And we realize that at leg 1, okay, the plot is significant. So that one is non-seasonal. So it's not what we are asking. So then he said leg 2 is insignificant, leg 3 is insignificant, but when it comes to leg 4, it's significant. Okay. Then leg 5 is not, 6, 7 are not, but 8 is significant. So in other words, for seasonality, we've got leg 4 and leg 8 because both of them are significant. Okay. So now, because it's an autocorrelation function plot, we are expecting to see SMA of order something. So the question is of order what? It's going to be of order 2 because we stop at what? At this one. Okay, if you have stopped here, if this, or maybe if like 8 is insignificant but like 4 is significant, we will be having SMA order 1. The issue is at seasonalities, at like 4 is significant, so that is why we're having this one. But at like 8 is not significant, so that is why we're having this one. But if like 8 and like 4, all of them are significant, we're having SMA order 2. That S is very important because it indicates the seasonality. So that is why we consider only 4 and 8. Why 4 and 8? Because here we are considering as it is what? It is a quarterly data. But if it is a monthly data, we will be having for moving average, we'll be having 0 because there is no significant peak or at like 12. So it's supposed to have a 12 to indicate that indeed you are dealing with the monthly data, but you don't have like 12. Like 12 is insignificant, so that's why you don't have that. But at like 4 and like 8 are significant, so that is why we're dealing with what? SMA of order 2, which is this one.
Okay, thank you, sir.
Okay, so
So
now let's
say,
go to the partial autocorrelation
say,
function. Yes.
say, like, oh, okay, if the autocorrelation, it is there, but let's say at leg 1, it is there, but it's not significant.
Yes.
So, like, what are we, yeah, like that, what are we having?
So in this case, this one we don't have it because this one is insignificant. So it's not there. So, and we are having autoregressive of order like 4 and like 8. So we are going to have only this one. Only having this one. SMA 2.
Okay, so we
So in
aren't
this,
going to measure about the availability of the autocorrelation at that particular leg.
yeah, you have to check, yeah, the availability of that.
We aren't going to measure about the availability, but we are going to measure about the significance.
Yeah, the significant part of the legs. The availability,
So
the leg can be available but insignificant.
yes, that's what I am trying to understand, whether if, okay,
Okay,
as
you're
I am
right.
asking, like, the autocorrelation is there at leg 1, but it's not significant.
Yes.
What is it? What's the idea
So in that,
behind? Or say probably we are having the autocorrelation is there at leg 2, and it's also not significant. So like I just want to understand the notion of being significant and being insignificant, and how
yes,
does it
no,
affect the availability of the particular model.
no, it doesn't affect the availability. The peak can be available but insignificant, so it doesn't affect anything. So if it is insignificant, you don't consider it, you just leave it as it is. Then we consider those that are significant and check at what leg is it significant. If it's significant at leg 1, so we are expecting moving average of order 1. If the significant is at leg 2, we are expecting moving average of leg 2.
But when they are significant,
Yes, when they are significant. We're dealing with the significant peak here. The peak can be there but insignificant. For example, this is like 2, okay? It can be there. You find that it's there, but it's insignificant. You see, it's within the limit. And this one can be there. You find that it's not significant, but it's within the limit. So we don't consider that one. We consider these ones that are significant. This one that are significant. So which one is significant? It's at leg 1. So that is why we're having moving average of order 1. Which one here at leg 4 is significant? So that is why we're dealing with what? SMA of order 1. This one again at leg 8 is significant. So that's why we're dealing with what? SMA of leg 2. I don't know whether you
Sir.
Hmm.
Sir, I would like you to do an example. Maybe write somewhere after the Sarima. That's right. When we don't have the moving average, we only have the seasonal moving average and the autocorrelation, auto-regressive only. So how do we go about finding that module? Just write that module. Maybe we may understand, or some of the students which are quiet, this thing can be helpful to them also.
Okay, what you're saying is, come again?
Saying when we don't have the moving average, but we only have the seasonal moving average and the auto regressive. But
In writing.
yes,
If how can I put it? If we have a seasonal moving average of order, say 2, and
maybe we have an autoregressive of order 1.
Okay, which is seasonal or non-seasonal?
It can be seasonal, sir, to make things
and
simple.
seasonal and seasonal auto regressive of order 2. Let me just take 2 all of them. You see this statement, it says we have a seasonal moving average of order 2. What does that mean? It means we have got SMA of order 2. Is this statement. You get that? And then the second one, a seasonal autoregressive of order 2. So you have got SAR of order 2. Is it clear?
Yes, sir.
So in this case, let's go to the plot. Okay. Remember, for seasonal moving average, you check autocorrelation function plot. Okay. So here you have got ACF plot for this one. Okay. And here you have got the PACF plot. Okay. So it's where you have to check these things. So now
we take advantage of the fact that the autocorrelation function of the moving average, it is cutting off. And
yes.
the partial autocorrelation function of the autoregressive process is cutting off. So we are taking that to be on our side whenever we are analyzing these kind of problems.
Yes. Okay. Now let me just go to the plot on this case. So you have got row K here. Yes, like K. So remember SMA. So here you have got 0, 1, 2, 3, 4. So and remember, for seasonality, I don't know whether do you want me to consider the quarterly data or the monthly data?
The quarterly, sir.
To simplify things, the quarterly.
Okay, 2, 3, 4. Let me just see this 1, 2, 3, 4, 5, 6, 7, and then 8. Okay. And then from there, You have got the limits there. Because it's seasonal moving average of order 2, so you have got this. So seasonal. So this is the plot for seasonal moving average. The only peak which is significant is at like 8 there. Okay, now let's come to this partial 5kk. They're going to be the same because it's 1, 2, 3, 4, 5, 6, 7, and 8. They're going to be the same. This is the limit. So again, it's going to be this is a significant peak. The rest, they are insignificant. It can be here, it can be like this one, it can be like this one, as long as it's within the limit. Or it can be 0, as long as they are within the limit. But the one that is significant is only 1 at like 8. So this one is this, and this one is this. So now, if you just want to write it, the combination of the two now as what? As armor. So if you want to write them as armor.
Sir,
Yes?
so what's the difference between the first plot and the previous one from the previous slide?
From the previous page?
Yes, the first one and the one on the previous page.
This one and that one?
Yes.
Yeah, you can say that there's no different here, except that this one is significant. But if you just want to consider this one, so this one is where it comes in. But for this one is this one, which is the same as that one.
Yeah, I'm talking about the seasonal part. Is it not MA2 when we have peak at 4 and 8?
Come again?
Is it not seasonal of order number 2 if we have peak at number 4 and number 8, if we have 2 peaks?
Oh, you said it's not this one and this one because they are seasonal. Yeah, because it's like there's no way you can just jump to this one without the having number 4, quarter number 4. Sometimes you can find that even this one is significant. So the same applies to this one, but normally sometimes you can find that where is it? You can find that both here, isn't it? We were just considering this one, so you can just find that even this one, if it's significant, it doesn't affect anything. It's going to be the same because isn't that it's quarterly 4 and 8? It's still the same. If it's there or it's not there, as long as the last one is 8 there, it's going to take you there.
As long as the last one is 8, we can have seasonal.
Yes.
Okay.
So now let's go to Sarma now. Sarma, because isn't that their seasonality? Remember, there is no non-seasonal part. In other words, for both moving average and the what? Autoregressive, they are zeros. You remember?
Sir, can you go to that first diagram, the previous one? Can you go to the previous slide? Again. Again. Yeah, here. So, sir, will I be wrong if I say this plot represents MA1 and S.
MA, immediately when you say MA, it's wrong.
AR, sorry, AR.
Okay,
If
AR.
I say AR1 and SAR1.
SP.
S.
And SAR1.
AR1.
Yeah, you are
because
wrong.
Of,
because there is here in that plot, there is no seasonality. It's only non-seasonal. That's why we're having this.
Because
You
of
see,
that
the legs is
picture.
like 1, 2, 3, 4, 5. But if you are considering the are you saying this one is significant?
Yes.
Oh yeah, if this one is significant, so it's fine because it's going to be like this one because it's a what? It's a quarterly data, so it's okay. It's okay if you like
Sir,
it's like that.
sir, on what Christopher is saying, sir, okay, if you are not given this S, how will you know or it's S? When we don't know S, I don't think we should conclude based on the seasonality. We don't have any seasonality again.
Yeah, isn't that they will okay? They will explain to you that the data is seasonal. So immediately when they say seasonal, if it's like this one, so and this peak is significant, so obvious there is a seasonality. Okay. They will explain that. If they didn't talk about seasonality, they talk about armor. You see this one, it doesn't have a seasonality. So obvious, we just assume that there is no seasonality. It's either maybe they're considering what the monthly data, which we don't have 12 here. So it's only 4. So that means there is no seasonality in a monthly data in this case. But anyway, they have to explain to you that there is a seasonal data there. So identify. That is why in many cases we said identify the model as SARMA. You see now, immediately when we say as SARMA, we are referring that there is a seasonality there. But if they said identify the model as ARMA, so therefore we excluded the seasonality. So the model doesn't have a seasonality. So if you are considering this plot here, so you can consider 4 as a seasonality there. I don't know whether it's clear. Anyone?
Yes, sir.
Sir,
Clear. Yes.
sir, how do you know when the peak is not significant?
Isn't it? I said you have to check the limits there. But in those cases that they don't give you the limits, but they give you only the 2 peaks, which is big, so it's just significant. So the rest they are going to be 0 if there's no such limits there. But normally the limit is supposed to be there to check whether indeed the peak is significant or not.
Sir, sir, the question we were doing, the last one, sir, I'm fine with it. I understand it now. You can leave it. You can continue with our stuff, or they can ask. But on the case which you were doing that thing, I wanted to understand, or do we include zeros in our Sarema? But now I'm fine since I saw.
Okay. No, but I think it assisted a lot of students.
Yeah, I think so too, sir.
Okay, thank you very much for that question. Okay, I don't know where I was, but I think we haven't done the one for partial. Okay.
We're still trying to write that
Oh, it's Sarma something. Yeah. Okay, but at least it's a continuation of that question of that guy. Sarma 00 I said 0, 0 because we don't have the significant peak in non-seasonal part. Okay, so that is why it's 0, 0. So now for autoregressive, we have 2, ne? Yes, because it's 8. Okay, and then for moving average, again we've got 2 because it's 8 here, because all of them are 8, so it's 2. Then for seasonality is 4. And again, if you take this 4 and multiply with this 2, it must give you 8 there. 4 and 2, it must give you 8 there, to show that it's of order 2. So this is if you don't want to write it like this, you can write it as what? As no, because it's including everything, it will be difficult. No, it's fine like this one, because it's including both autoregressive and moving average. Okay, it's fine. It can't be SAR224, because if you do that, you are excluding moving average, and it can't be SMA224, because when you do that, you are excluding autoregressive. So I think it's better to leave it as it is. Any question? I think I covered everything most.
Well understood, sir. We can continue, sir.
Yeah. Okay, so that is what I wanted you to understand from where we stopped last time. So,
Sir,
but now, yes.
I have a question.
Yes.
That slide you just posted before this one, I think it's after this one.
After this one. This one.
Yeah, this one. You see the seasonal of moving average 2. Is there supposed to be one significant lag?
No, isn't it? We said that even if this one is significant, this one there.
Yeah.
The thing is, this one is the last one, so that's why it's taking us to be 2 there.
Oh, okay.
So it can be significant or not significant, but it doesn't change this.
Okay, well understood, sir.
Okay. Now let's go to which one? Yeah, let's go to page 18 of our lecture notes. Where chapter 2, you still remember that we left some of the topics there, then we said we will come back to it. The one for Box Jenkins, page 18, Box Jenkins. Can I go to the next slide?
Yes, sir.
Okay, thanks. I'm referring to chapter 2, page 18 for your reference. Model building. Okay. Now, based on this guy called Box and Jenkins, there are 3 main stages of model building. Can I say based on Box and Jenkins. Model building. There are 3 main stages of model building. So in other words, if you want to build a model, you have to go via 3 steps. Number 1, you have to identify a model. Stage number 1 is called model identification. You identify a model. That's number 1. Number 2, you estimate the model. Call it model estimation. In other cases, they call it model fitting. Fit the model. Number 3, you have to go via diagnostic checking or model diagnostic or diagnostic checking. Those are the 3 important stages of building a model. So now, number 1, which is identification. Identification is the one that we have been doing here. You identify a model. Okay, it's either you want to identify ARMA, SARMA, SARIMA, and so on. And to do that, you are supposed to have ACF and PACF plots. To identify the model, you're supposed to have autocorrelation function plots and partial autocorrelation function plots. For autocorrelation function plots, this is where you have to identify a moving average where it cuts. Partial autocorrelation function plots, this is where you have to identify where autoregressive process cuts. Okay, this one we've done. I think you are familiar with. So number 2 is to estimate the model. How do we estimate the model? There are 3 things that you have to apply in order to estimate the model. Number 1, you use what we call mean. Is it called minimum mean square error estimate? MMSE. Or is it minimum square error or minimum? Let me just check it for you.
Minimum least square error, maybe.
Least square error is another one.
No, it's fine. Say it's minimum mean square error. Yes, MSE.
Square error, yes. So number 2 is a least square error, the one that we are referring to. Okay. And the third one is a maximum. Maximum what? Likelihood. Estimate. Those are the 3 things that you have to do when you want to estimate the model. But in our case, we are going to consider in this model, or in this module, sorry, we are going to consider this one and this one only. Okay, so the maximum likelihood.
So what's the second one?
Least.
What's the second one? Okay.
So we're going to use MMSE and LSE, but maximum likelihood, no, we're going to not consider that one. So number 3, diagnostic checking. How do we check the data now? So in this case, we check the residual autocorrelation. Yeah, we check the residual autocorrelation. Residual autocorrelation, we are referring again to what? Residual ACF. This one is a residual ACF and residual PACF. In this case, you are going to check these two plots. There is a residual ACF and a residual PACF. So those plots, you check again the peak. If all of them are insignificant, are within the limit, so the data or the process is a white noise or purely random process. We check ACF plot, residual ACF plot. If all the peaks are insignificant, in other words, they are within the limits, so the data it's a white noise or it's a purely random process. So in other words, residual ACF and residual PACF, their peaks must be insignificant for the data or for the process to be a white noise or purely random process. So let's go to the example. How do we apply that? I think we have the example. Page 19, example 2.2.1. It's no longer visible.
Just right. Just want to see.
Bro. Okay, I'll stay together.
Yes, sir. We're together, sir.
Yes, let's consider this example. Oh, sorry. What is happening now? See now, it's no longer responding. Yes, I want this page. Okay. Now, on page 19, there is example 2.2.1. Okay. It says we have got two example 2.2.1. It says we have got 200 observation. Oh, before that, let me just give you this. Before this example, sorry for that. Give you this information before we treat that one. Let's say a process, or let's say a data or a process is a white noise. Sometimes we call it purely random process. It's purely random process. If the absolute value of the estimate autocorrelation functions, this is the absolute value of the estimated autocorrelation functions, are less than 2 over the square root of n, where n represents the sample size, or sometimes if the sample size is not given, you can use the population size. You get this statement? It says a data or a process is a white noise or purely random process if the absolute value of the estimated autocorrelation function is less than 2 over square root of n. So now let's consider this example now. To apply this, consider example, sorry, example 2.2.1. Okay. let's say you've got 200 observations. Okay. On stationary series. And then the following sample.
Sir, actually, I want to ask you, since the class reps they are not doing their jobs for breaks, our minds are congested now. We need a break. That break, it's important to say.
But now it's time off.
You can finish for today, but that break, we need that break.
Yeah, I'm sorry, very sorry for that. Next time I'm going to consider that. Just because when you take a break, when you come back again, it's like I prefer to do everything. Then we stop at 22 to 1.
Fine if we could just continue, but give us that 10 minutes, because we are not doing time series alone again. We have these things.
Yeah. Yeah, no, it's point taken anyway. Or maybe let's stop here. We're going to do.
Yes, it's fine.
Because
We
our
can
time
stop. Yes. It's
yeah.
almost
Let's
up.
stop here. We are going to continue with this next time anyway. And then let me just remind you that we are still going to meet at 20 to 3. Is it 20 to 3? 10 to 3, where we are going to talk about the quiz. I'm going to give you the feedback, so we are going to talk about that next time. And thank you very much for your time. Unless if you have any question.
So, sir, we are going to do those sample estimates together, checking their biasness for the mean variance. I'm asking if we are going to do those sample estimates for the mean variance, covariance, rows.
Yeah, we're going to do them.
Spatial autocorrelation.
Yes, we are going to do that.
And check their biasness.
Yes.
Okay.
We are going to do that. Thank you very much.
Okay.
Say.